Explain the universal law of gravitation. Here, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So when we have two objects, there is always a force acting between them which is directly proportional to the product of the masses. So F is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. And if you put them together, both these, you get m1, m2 over d square. The proportional sign you put equal, then you have a constant which is g, gravitational constant over d square. So this is the force for between two objects having mass m1, m2 kept at a distance r from each other. Who found out the law of the value of gravitational constant? That is Henry Cavendish. An object weighs 10 newtons when measured on the surface of the earth. So the weight on the earth is 10 newtons. What would be its weight when measured on the surface of the moon? Now we know the weight on the moon is 1/6 the weight on the earth. So this would be 1/6 into 10 newtons, which is 1.67 newtons. So it's exactly what they've written here. We know that the weight of an object on the moon is 1/6 the weight on earth. So weight on the moon is weight on the earth divided by 6. What is the acceleration of free fall? The acceleration of free fall is 9.8 meter per second squared. G is 9.8 meter per second square. A man's weight when taken at the poles is 600 newtons. Will his weight remain the same when measured at the equator? Will there be an increase or decrease in his weight? Explain. Now, no, his weight will not remain the same. And this is because we see that the earth is not a perfect sphere. It is slightly flattened at the poles and bulging at the center, which means the radius at the pole is small while the radius at the equator is large. Now if the radius is small at the pole, the acceleration due to gravity here is large. Here the acceleration due to gravity at the equator is small, is less. So if acceleration due to gravity is large, weight is large or great, and here weight is small. So as we move from the pole to the equator, from pole to the equator, we find the weight decreases. The weight becomes less. And this is exactly what is written here. There is a decrease in weight at the equator. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles, decreasing towards the equator. The force of gravity decreases from pole to equator. The radius increases from pole to equator, radius increases. So acceleration due to gravity decreases, and hence weight also decreases. Give reason. The stone falls towards the earth, but the earth does not rise towards the stone. Here the stone falls due to gravitational force of the earth, but the earth do not move towards the stone, and this is because the mass of the earth is much more than that of the stone. So since the mass of earth is large, and the acceleration due to gravity will be less, very less, negligible. Two objects kept in a room do not move towards each other as per the universal law of gravitation. Why? So if I have two objects, say M1 and M2, there will always be a force of attraction between them, but the objects do not move towards one another because their masses are small, and since the mass is small, the force is also small. So here we say the mass of the two bodies is very small, therefore the force of attraction between them is very small. So both the objects do not move towards each other. Two objects of masses M1 and M2 are dropped in a vacuum from a height above the surface of the earth. M1 is greater than M2. Which one will reach the earth first? So we have two objects, M1 which is a large object and M2 which is a small object, and they are dropped to the surface of the earth. Now both will reach the earth in the same time. They will take same time to reach the earth, and this is because acceleration due to gravity is independent of the mass of the object. The mass of object. So both will reach the ground at the same time because the acceleration due to gravity, which is small d, g, is independent of the mass of freely falling bodies. If the moon attracts the earth, why does the earth not move towards the moon? So you have the earth that is large, and then you have the moon which is smaller. So this is the moon, and here is the earth. Now both attract each other with the same force. The moon attracts the earth also attracts with the same force. We do not see the earth moving towards the moon because the mass of the earth is large. Mass is very large, and because the mass is large, the acceleration is small. In fact, the acceleration is negligible, so we do not see it moving. So here, the moon and the earth experience equal gravitational forces from each other. However, the mass of the earth is much larger than the mass of the moon. Hence, it accelerates at a rate lesser than the acceleration rate of the moon towards the earth. For this reason, the earth does not move towards the moon. Again, I repeat, the mass is large, hence acceleration is negligible. It's negligible, can be neglected. Which forces causes things to fall towards the earth? And that is a gravitational force. An object is thrown vertically upwards and rises to a height of 13.07. So here we have an object that is thrown upwards. When an object is thrown upwards, its final velocity is 0, and the g will be, in this case, negative because the object slowly stops. It's retardation that takes place. And here they said it travels to a distance of 13.07, which is the height, or we can say it is a distance, is 13.07 meters. So the distance traveled, this is the height, the final velocity is 0, the acceleration is minus 9.8 meter per second square. And then you use the formula v square equal to u square plus 2as. Now when a body goes up, the as can be written as here 2gh. You put your values. This is 0. Your u you do not know. 2g is minus 9.8 and this is 13.07. So 0 equal to u square, this is minus 256. So 256 equal to u square, and u is under root of 256. So u will be 16 meter per second. So here we have 16 meter per second. The next part of the sum, we need to find the time. To find the time, we use this formula v equal to u plus 80. Now we know v is 0, u we found out is 16, a we know is minus 9.8, and this is time. So 9.8 t equal to 16. So t is 16 over 9.8. So time becomes 1.63 seconds. Mention any 5 phenomena that the universal law of gravitation was able to explain. The first one is, it explains the force that binds us to the earth. It also explains why the atmosphere remains close to the earth. The gravitational force of the earth keeps the atmosphere close to the earth. Then the motion of the moon around the earth is explained by universal law of gravitation. The gravitational pull of the sun, which keeps the planets revolving around the sun. And last, the tides formed by rising and falling of the water level in the oceans are due to the gravitational force of the moon and the sun. A stone is thrown vertically upwards. So again here the object is vertically upwards, which means the v final velocity will be 0 and the acceleration due to gravity here will be negative. Here they've given it as 10, we're going to take as minus 10 because for an object that is moving upwards, it slows down, there's a retardation. And here they have said that it is thrown with a velocity of 40 meter per second. So u is 40 meter per second. So we use the formula v equal to u plus 80 or gt. We put our values and we get the time as 4 seconds. Now to find the distance, we will use the formula here. S, or instead of S, you can write in this case as h. h equal to ut plus half gt square. It is the same thing as S equal to ut plus half at square. So here the u is given u, this is u, and then we have t, that is the time, then half gt, g we know is minus, and t square. You work this out to get the answer 80. So it goes up 80 meters, and it comes down 80 meters. Of course the displacement will be 0 because it comes back to its initial position, but the distance covered will be 80 plus 80, which is 160 meter. Give the difference between acceleration due to gravity, small g, and universal gravitational constant, capital G. So first is acceleration due to gravity is acquired due to the Earth's gravitational pull on it. The gravitational constant is equal to the force of attraction between two masses of 1 kg separated by a distance of 1 meter. This is the definition of gravity, acceleration due to gravity and universal gravitational constant. So first point is the definition. Then for the second point, acceleration due to gravity is a vector quantity, but gravitational constant is a scalar quantity. Now the small g is different in different places. It varies from one body to another. Moon, the acceleration due to gravity of the moon is different from that of the acceleration due to gravity of the earth. But G is a universal constant. It remains constant throughout the universe. And here G, we know the value of G is Gm over r square. Here it depends on the size and nature of the bodies. Here it does not depend on the size and nature of the bodies. What do you mean by acceleration due to gravity? Acceleration produced in a body due to the force of gravity is called acceleration due to gravity. It is denoted as G. The value is 9.8 meter per second square, or 9.8 meter second minus 2. This is at sea level. As we move higher, the acceleration due to gravity decreases. According to the Universal Law of Gravitation, every object in this universe attracts every other object. Explain why then a table and a chair lying in a same room do not collide with each other. And the reason is because the force is very weak. The gravitational force is very weak and it is unable to move the bodies. So the gravitational force, again I repeat, is very weak because it is F equal to G m1 m2 over d square. This G is 6.673 into 10 raised to power of minus 11, and this is a very small quantity. Hence G is very weak and is unable to move the bodies. Next, an object is thrown vertically upwards. Again here we have object thrown vertically upwards. That means final velocity is 0 to a height of 12 meters. So the height here is 12 meters. Calculate the velocity with which it is thrown. So the u we have to calculate and we have to find the time. So the height is 12, final velocity is 0 for a body thrown upwards. The g is minus 9.8 meter per second square. We have to find u and t. So for this we use the formula v square minus u square equal to 2gh. You put your values and you get your u as 15.33. And to find your height, your time, you do v equal to u plus gt. Put your values in this and you will get your time. Why is the weight of an object on the moon 1/6 the weight of the earth? Means the weight on the moon will be weight on the earth divided by 6. And why is that so? First let us calculate the g on the moon. It will be m, mass of the moon, over the radius of the moon square. So here the mass of the moon is given, here is the radius of the moon, gravitational constant is this, and then we have, this is the formula for G. I repeat again, G equal to G m over r square. You put your values and you get yours as 1 point on the moon as 1.63 ms minus 2. And we know the G on the earth is 9.8 meter per second square. So when we divide the G of the moon and the G of the earth, that is 1.63 over 9.8, approximately we get the value 1/6. So the acceleration to gravity of the moon is less than the acceleration to gravity of the earth. An object is thrown vertically upwards. Again, it's vertically upwards means final velocity 0 meter per second. Acceleration due to gravity is negative for thrown upwards. And height is given as 10 meters. So we need to calculate the velocity with which it is thrown. So u we need to calculate, and the time. So here we have distance is given as 10, final velocity is 0, acceleration due to gravity is of course minus because it is upwards. So we have v square equal to u square plus 2as. You put the formula here, you put your values, and you get your u as 14. Here we'll do it, v square equal to u square plus 2as, which is 0. U we do not know. 2a is minus 9.8 and your s is 10. So you got your u square equal to 196, u equal to under root of 196, which is equal to 14 meter per second. And the next you need to find v equal to u plus 80. So we have v equal to u plus 80. V is 0, u we found is 14. We know g is minus 9.8, or acceleration to gravity, and the time you need to find. A ball thrown up vertically returns after 6 seconds. So to go up and come down, total time is 6 seconds. Therefore, to go up, it will take half of it, that is 3 seconds. So the time taken by the ball to reach the maximum height will be 3 seconds. And it is first thrown up, so we take v equal to 0. So we use the formula v equal to u plus gt. This is 0, this is u, g is minus 9.8, and this is 3. So on working this, you get your u as 29.4 meter per second. So here is the u. In the second part of the sum, we need to find the maximum height. To find the maximum height, we use the formula s equal to ut plus half gt or at square. So u we already found here is 29.4. Time we know is 3. 3 to go up, 3 to come down. So total time 6. Half, and we know the g is minus 9.8. 3 is 3 square. You work this out and you get the answer 44.1 meter. So here is 44.1 meter. The position of the ball after 4 seconds. So now after 4 seconds, it has gone up for 3 seconds, and then it will come down 1 second. So this is its position after, here is its position after 1 second. So u equal to 0, the body is coming down, u is equal to 0, time is 1 second, and you put the formula, you got h equal to ut plus half gt square. So h equal to 0 into 1, half minus 9, this is plus because it is coming down now, t square is 1 square. So you got h is 4.9 meter. So I repeat that. They asked us after 4 seconds. Remember, to go up it took 3 seconds, and then it will start coming down. So this is say 1 second. So 3 plus 1, 4. So after 4 seconds it will be at this point. So we have to do the calculation for this portion only, for this coming down, where u equal to 0, g equal to plus 9.8 for coming down, 1 second for coming down, and then we put the values.